areas of basic figures, but this time you're going to have to do a little bit more work to find the pieces to be able to find the area. So a few rules to review. So if we have two sides of a right triangle like we do in that first one, we're going to use the Pythagorean Theorem. So remember that the Pythagorean Theorem is a squared plus b squared equals c squared, where c has to be the hypotenuse. So across from the right angle, that has to be c. So we'll take those other two sides. We got 7 squared plus x squared equals 14 squared. We know 7 squared is 49, and 14 squared is 196. So we need to subtract that 49 from both sides. So x squared equals 147. Then we'll take the square root of both sides to get x by itself. And when we pop that into our calculator, it's going to tell me my answer is 7 square root 3. This next triangle is a 45, 45, 90 triangle. I know that because I have two 45-degree angles and a 90-degree angle. So we know in a 45, 45, 90 triangle that the legs are congruent. So that means that these two lengths right here are going to be the same. So that tells me that right here, y is equal to 25. So we figured out that our leg is 25. That's what's going to go over 1. Our hypotenuse across from that right angle is x. He goes over the square root of 2. Then we'll cross multiply. 1 times x is x. The square root of 2 times 25 is 25 square root 2. This next triangle is a 30, 60, 90 triangle. I know it's 30, 60, 90 because I have a 30, a 60, and a 90. So my short leg is always across from my 30-degree angle, so that's my short leg. My long leg is always across from my 60-degree angle, and the hypotenuse is always across from the right angle. So my short leg here is 15, he'll go over 1. My long leg is y, he'll go over the square root of 3. My hypotenuse is x, he'll go over 2. So we'll take a fraction that just has just numbers in it, 15 over 1, and we'll set it equal to a fraction with a variable in it, so maybe that y, and we'll cross multiply. 1 times y is y. The square root of 3 times 15 is 15 square root 3. To solve for x, we're going to take that fraction that has just numbers in it, 15 over 1, and set that equal to a fraction with that x in it, and we'll cross multiply. 1 times x is x. 2 times 15 is 30. In these next two triangles, we're going to have to use trig ratios, so sine, cosine, and tangent. I have those up there for you in case you forgot what the relationships are. So the first thing we want to do is we want to be able to go through and label up these sides. So that's what we'll do first. So here's the angle that they gave me. Across from that is the opposite side. Across from the right angle is the hypotenuse. And the side that's left over is the adjacent. I didn't get anything for the opposite side, so I'm going to ignore him. We have an adjacent and a hypotenuse, so that means I'm using cosine since he uses adjacent and hypotenuse. So I'll have cosine of A for angle, so that's 38, is equal to the adjacent side over the hypotenuse, so x over 40. We'll go ahead and take that cosine of 38 and put him over 1, and we'll cross multiply. 1 times x is x, and then we'll take 40 times the cosine of 38. And when we pop that into our calculator, we should be getting 31.5. Oops. Okay. On this next one, we're going to be using trig ratios again. So once again, we're going to label up our sides. Across from that angle is my opposite side. Across from the right angle is the hypotenuse. And the side that's left over is the adjacent. So they didn't give me a hypotenuse here, so I'm looking at only opposite and adjacent. The trig that uses opposite and adjacent is tangent. So we have tangent of A is angle, so that will be 66, equals opposite over adjacent, so x over 18. I'll put that tangent of 66 over 1, and we'll cross multiply. 1 times x is x. Then we'll take 18 times the tangent of 66. And when we put that into our calculator, we'll get 40.4. Those ways to find lengths of triangles reviewed, let's find the areas of these figures. So we know the area of a rectangle is going to be base times height. So this guy down here is going to be my base. And this guy right here is going to be my height. So we know we have a 30, 60, 90 triangle in there since we have a little right angle right there and the 30-degree angle. So across from that 30-degree angle is my short leg right there. And my base will be my long leg. So based off of the 30, 60, 90 rules, we know that our short leg, or the height, is going to go over 1. The long leg, or in this case our base, is going to go over the square root of 3. And the hypotenuse will go over 2, so we'll have 10 over 2. So to find the height, we're going to take the fraction that just has the h in it, so h over 1, and set that equal to the fraction with just numbers in it, 10 over 2. So we'll take 2 times h and get 2h equals 1 times 10 is 10. We'll divide by 2 on both sides. So now we know that our height is 5. So I'm going to go ahead and erase this. This is 5. Here's my height. So now we'll find that base. We'll take the fraction that has base in it, b over the square root of 3. Set that equal to the fraction that has just numbers in it, 10 over 2. We'll take 2 times b and get 2b. We'll take the square root of 3 times 10 and get 10 square root 3. We'll divide by 2 on both sides, so my base will be 5 square root 3. So when we're going to find this area, I'll take the base, which was 5 square root 3, and multiply that by my height, which was 5. So remember, when we're multiplying together numbers with radicals, we multiply the same types of numbers together. So 5 and 5 are both normal numbers, so that'll be 25, and then the square root of 3 comes along for the ride. So that'll be 25 square root 3 centimeters squared. All right, let me go ahead and draw a little line so we can keep these separate. All right, so this next guy, he's a parallelogram because opposite sides are parallel. So in a parallelogram, we know that the area is going to be base times height. So we know that our base and our height always make a right angle together, right? So that's why we need this right angle. So whatever this length is right there is going to be the height of my parallelogram. 16 is going to be that base. The 5 is along that dotted line. That's not part of my figure. That's there to help me find out what the height is. So in here we have this little pink triangle, right? So to find one side of that right triangle, I'm going to have to use the Pythagorean Theorem. So a squared plus b squared equals c squared. 13 is going to be c since it's across from that right angle. So we'll have 5 squared plus h squared equals 13 squared. We know that 5 squared is 25, and that 13 squared is 169. We'll subtract 25 from both sides. So h squared equals 144. Then we'll take the square root. So we know our height is equal to 12. All right, so we'll find that area. Our base was 16. Our height is 12. So when we multiply together 16 times 12, we're going to get 192. And that will be centimeters squared. Okay. This next figure is again a 45, 45, 90 triangle. The reason we know that is because it has a 90-degree angle and the legs are the same. So we know it has to be 45, 45, 90. So with 45, 45, 90s, remember the leg, we'll just call that x because we don't know what it is. We put him over 1, and then we take the hypotenuse, which is 12, and put him over the square root of 2. And we'll cross multiply. Square root of 2 times x equals, times 12 is 12. When we take 12 divided by the square root of 2 in our calculator, we're going to end up with 6 square root 2. So what that means is that right here, this is 6 square root 2, and so is this leg. So when we are on our way to find the area of this triangle, we know a triangle is 1/2 base times height. Our base and our height always make a right angle together, so 6 square root 2 is my base, and 6 square root 2 is also my height. So we have 1/2 6 square root 2 times 6 square root 2. And when we put those into our calculator, we are going to end up with 36, and that will be centimeters squared. Okay, in this next one, the top and the bottom sides are parallel to each other, but those left and right sides are not. So that means that this is a trapezoid. So I'm going to write down the area of a trapezoid formula where we add the bases together, multiply by the height, divide that whole thing by 2. So let's see what information we have so far. So that 12, he's going to be one of our bases. 8 isn't the height or another base, so that's really all we have. So we need to find out a couple of other distances here. So what we've got going on right here is a 30, 60, 90 triangle. Okay, I'm going to draw that separately over here. This is 8. This is my right angle. This is my 60-degree angle. Cool. All right. So I'm going to need both my short leg, let's call him S, and my long leg, let's call him L. So 30, 60, 90. Let's see. So my short leg is S. He goes over 1. My long leg is L. He'll go over the square root of 3. And the hypotenuse in that guy is 8. He'll go over 2. So to find the short leg, we'll take the fraction that has a short leg in it and set that equal to the fraction that has numbers in it. And we'll cross multiply. 2 times S is 2S. 1 times 8 is 8. So that means my short leg is equal to 4. So this length right here is 4. This length right here is 4. To find the long leg, we'll do the same thing. Long leg over the square root of 3 equals 8 over 2. We'll cross multiply. 2 times L equals 8 square root 3. We'll divide by 2 and get 4 square root 3 for that long leg. So here's what we just figured out. We know each of those little bits is 4, and we know that this middle part right here is 12. So this entire length, 12 plus 4 plus 4, is 20. That's my other base. I know that my height always makes right angles with the bases. Since I have a right angle right here, that means 4 square root 3 is going to be my height. So now we'll put in everything we know into this formula. One of my bases is 12. We figured out the other one was 20. We figured out our height was 4 square root 3. And we'll take that whole total and divide it by 2. And when we pop him into our calculator, we're going to end up with 64 square root 3. And that will be centimeters squared. So this next guy is a rectangle, so we know we're going to be taking base times height. Well, you know we have a right angle right here, so that makes this length my base, and this length over here my height. So if we label up these sides for sine, cosine, and tangent, opposite, hypotenuse, adjacent. So my height is the opposite side. The 12 is the adjacent side, since this guy over here is the hypotenuse. Opposite and adjacent mean we're going to have to use tangent. Remember, tangent of an angle is the opposite side over the adjacent. So we'll have the tangent of our angle is 70 equals opposite, which is h, over adjacent, which is 12. We'll put that tangent of 70 over 1, and then we'll cross multiply. We'll take 1 times h and get h. And then we'll take 12 times tangent of 70. Oopsies, forgot the 12 first. When we put that 12 tangent of 70 into our calculator, we're going to get 32.969. So if I wanted to round to the nearest tenth, I would have to round up that 9 to the next guy, right? So we're going to round him to 33. You always want to round to the nearest tenth. That's 1 decimal place. When I wanted to round this to 1 decimal place, I had to round that 9 up, so it becomes 33. All right, so let's go ahead and find that area. So we know our base is 12, and we just found out that our height is 33. And then when we multiply those together, we're going to get 396, and that'll be centimeters squared. All right, this next one, he's a triangle. So we know that the area of a triangle is 1/2 base times height. So down here, that 10, he's our base. That little piece that I just drew in, he's going to be our height. Now there's a little, we'll color him in. That little pink triangle. We know his hypotenuse is 13. We know this is going to be the height. So I know this is an isosceles triangle because these two little congruent marks, right? So when that height comes down, he's going to cut that bottom side right in half. So if we take 10 and divide it by 2, we will have a 5 right here. So to find the missing side, we're going to use the Pythagorean Theorem. So we'll take 5 squared plus h squared equals 13 squared. 5 squared is 25. 13 squared is 169. We'll subtract 25 from both sides, and we'll get 144. Then we'll take the square root, and we'll find out that our height is 12. So now we know that's 12. So to find our area, we're going to have 1/2. Our base was 10. Our height is 12. So when we pop that into our calculator, we'll get 60 centimeters squared. All right, good deal. See you guys later.